they really want you to buy the pro version so they don't have the 15-minute cutoff. But yes, I got cut off when just explaining very briefly. To segue from part 1, this is part 2 of the work and energy intro. The object, in this case a book, gained potential energy, even though, yes, it's true, the net work is 0. But the work done by gravity, the way I think about this is the work done by gravity was negative, and that's sort of like the price you pay for gaining the potential energy. It's a very loose, not quite rigorous way of thinking about this. What if Eli drags his soccer teammate, this has happened before, with an angled force? Now we're really going to explore this whole parallel concept. Hopefully, if I pause this, you can you pause this and think about this for a second. Your instinct should be to do a force diagram and then do some trig. Your force diagram looks like this, and when you do the components, which I had to write when my marker wasn't working well last year, you end up with 164 and 115. Here's my 200 Newton force. Here's my 20 Newton frictional force. Actually, I think I threw that in later as to discuss like what would happen if there was a frictional force. The work done by friction would always be negative. We'll get into that. So the work done by the parallel force, you're going to use the 163.8. I hope that's intuitive. And it gained kinetic energy, and particularly 655 joules of it, because that's the amount of work that Eli did on his teammate. The net work was also 655 joules. Again, ignore this 20 Newton thing. This is just me saying that there might be friction involved in a discussion last year. If there were friction, and let's say it was 20 newtons, then the net work be 20 newtons because he dragged him 4 meters. So that's taking away the 80 joules of work. If there were friction, the net work would be 575 joules. And it's the network that determines the amount of kinetic energy that was gained. And we call that the work kinetic energy theorem. Notice that, and you should write this down and think about it. Notice that the network in a problem like this, where you're calculating work, the network does not determine potential energy. The network determines kinetic energy. We can do some practice. Pause this. I'll show you the answers in the next slide. Here comes the next slide. I'll discuss the network and all that. If you do, let me just make sure these are actually the same questions. I just changed the format. Looks pretty good. Look at the answers. So part A, by gravity, when you lift, that's negative 30 joules. 30 joules of gravitational potential energy is gained. And for number 1, the energy type was also listed, and there's 0 net work. So part D, this should say 0 net work for number 1. Number 2, 20 newtons times 6. You may be saying, wait, that's a lot more than 60 joules. No, because you only want this parallel component. Only this parallel component, not the full 20 newtons, went into the cart. So 60 joules. The friction did negative 24 joules of work. There was no work done by gravity. And the types of energy generated, what did I skip D? Yeah, C and D. I don't know why I said E there, sorry. There were 24 joules of thermal energy generated and 36 joules of kinetic energy. 36 joules is also the net work. Does that make sense? Think about that. 36 joules is the net work, and therefore that's how much kinetic energy was gained. Now I'll show you a few questions. If you have time, you can look at these and get the explanations. You can mute me and just kind of pound through these. Since this object is moving to the left, and since there is a frictional force, oh, sorry, I'm getting ahead of myself. It just asks what is the work done by the normal force, and the answer is 0. No work is done by the normal force because the displacement is totally perpendicular to it. What about the tension? That's going to be positive 240 joules. What about the weight? That's going to be 0 again because it's totally perpendicular. What about friction? That's going to be negative 40 joules. Friction always does negative work. What about the net work done on this object? That's going to be positive 200 joules. The 240 joules done by the tension minus the 40 joules done by the friction, and technically plus the 0 and the 0. Now the object gained kinetic energy. Sorry, I answered that one kind of quickly. The amount of energy gained or lost by the object is always going to be equal to the net work done on the object. Well, that's not true. In this case, because we know it's kinetic energy, it's equal to the net work done by the object. If this object were being lifted, then the energy gained or lost, we'd also have to consider the potential energy, which is going to be the negative of the work done by gravity. In this case, they're talking about thermal or other dissipated energy. You should be looking at friction. And yes, friction did negative work, but the thermal energy that was generated is positive. It's there.